All right, let's talk about something that really changes the game in modern Java, the Stream API. Now, this isn't just about learning some new syntax, nope. This is about a whole new way of thinking, a more powerful way to process your data. It's a huge step into functional programming. Let's see how it all works.
Okay, let's start with a problem that I guarantee every single one of us has faced. You've got a list of numbers. Simple enough, right? But how do you actually work with them? How do you filter them, change them, and get a final result? We've all written the code to do this, but believe me, there's a much better way. So, to make this real, let's give ourselves a little three-step mission. First, we're going to take a list and filter it, pulling out only the even numbers. Then, for every even number we find, we're going to map it to a new value by doubling it. And finally, we'll reduce all those doubled numbers down into one single result by summing them all up. So how would we normally tackle this? Well, the first thing that probably pops into your head is a good old for loop, right? This is what we call the imperative approach, where we give the computer a super detailed step-by-step recipe telling it exactly how to do every little thing. You know the drill with the traditional approach. We'd start by creating some variable outside the loop, maybe call it sum. Then we loop through every single number, one by one. Inside the loop, we check, is it even? If it is, we double it, and then we add that new value to our external sum variable. It gets the job done, for sure, but we're managing a lot of moving parts ourselves. But hang on a second. Take a look at what's really happening in that code. Our three separate goals, filtering, mapping, and reducing, they're all jumbled up and tangled together in this one big block of logic. The what we're trying to do gets totally lost in the weeds of how we're doing it. The big picture is just gone. And this, right here, is why the modern solution is so fantastic. Java streams let us completely flip the script. We shift from that imperative style to a declarative one. So instead of telling the computer how to do all the work, we just declare what we want. It's a huge difference. You know, the best way to visualize a stream is to think of it like a data assembly line. Seriously, picture our list of numbers getting placed one by one onto a conveyor belt. Each number is now going to travel down this line, passing through different workstations, and each station has one very specific job to do. Our very first station is filter. Think of this as the quality control inspector. As each number rolls down the conveyor belt, this station looks at it and asks a question. In our case, are you an even number? If the answer is yes, it gets to move on to the next station. If it's odd, it gets pulled right off the line. Simple as that. So the next stop on our assembly line is the .map station. This is the transformation hub. Any number that made it past the filter station arrives here, and this station's job is to do something to it. It could reshape it, paint it a different color, or in our case, it doubles its value before sending it on its way. And we've reached the end of the line, the reduce station. This is where all of our finished products, those even numbers that have now been doubled, all end up. The reduce station's job is to take everything that's left and combine it into one single final result. For us, that means adding them all up to get our grand total. Okay, this is the moment where it all clicks. Let's put them side by side. On the left, you've got the tangled how-to logic of the for loop. But look at the right, the what I want stream pipeline. It reads like a sentence. You take the list, turn it into a stream, filter for the evens, map them by doubling, and reduce them to a sum. It's literally a description of the problem itself. So much cleaner. And hey, this whole declarative way of thinking isn't just for these big, complex operations. It actually makes even the most basic, everyday tasks way simpler and cleaner. Let's take a super common example, just printing every single item in a list. The old way, man, we've all written that for loop with the index I a million times, right? We have to manage that counter just to get to each element. But the modern stream-based way, we just use .for each. We're telling the list directly what we want. For each number, print it. It's just so much cleaner, way more concise, and it says exactly what it does. So let's zoom out for a second. After seeing all this, we gotta ask the big question. Why does this paradigm shift really matter for you as a developer? What are the actual tangible benefits of writing your code this way? So what's the big payoff? Well, first, readability. Your code just reads like a story describing the problem. Second, conciseness. You're just writing way less code to get the same thing done. Third, expressiveness. You cleanly separate the what you want from the how to get it. And finally, and this one is absolutely huge, no external state. Remember that sum variable we had to create and manage outside our loop? Gone. The stream handles all that internally. which makes our code way safer and a lot less likely to have bugs. At the end of the day, streams aren't just another feature. They're a tool that gives you incredible clarity. They let you build these powerful, elegant data pipelines that focus only on your business logic, not on the messy, low-level details of looping. So the real question is, now that you know how to build your own data assembly line, what are you going to create with it?